All right, welcome to U Substitution with Trig Functions. We've been learning in class how to how to integrate using U Substitution, and we're going to continue that, but this time we're going to use the Trig functions. So we're going to use the same process that we did before. We're going to identify U, find du, and then integrate. So on this first one, number 1, cosine 4x dx, we know that u is going to be 4x, du dx is 4, so du is going to be 4 dx. All right, so if we rewrite this, we have cosine 4x dx, and so we know we need a 4 and a 1/4. So if we rewrite this, we have 1/4 cosine u du. The integral of cosine is sine, so we end up with 1/4 sine u. We're going to substitute back, so this will be sine 4x and then plus c. The next one over here, we're going to let u be the part inside the parentheses, so u is 1 minus 3x. So du is going to be negative 3 dx. I skipped a step there. I hope you kind of followed along. Rewrite. I have sine 1 minus 3x, and then I'm going to move the 3 over with the dx. I'm close. I've got everything but the minus sign. So I've got the negative here and the negative 1 out here. If I rewrite this, I have negative 1 sine u, and then this is du. The derivative of sine, or the integral of sine, is negative cosine, so this is going to be cosine u, and u was 1 minus 3x plus c. Example number 3 has sine to the third, that's a 3, sine to the third power x cosine x dx. So remember that we can rewrite that as sine x to the third cosine x dx, right? And since this is the part in parentheses, we're going to let u be sine x. Okay, and so du would be cosine x dx. All right, so we can see here that we have that already. So I'm going to rewrite in terms of u. So I have u to the third du. Well, that's u to the fourth over 4. U is sine x, so sine x to the fourth over 4 plus c. And you, of course, could rewrite it this way, sine to the fourth over 4 plus c. Okay. Now, on the next one, we have the integral of tangent 10x secant 10x dx. We know that the integral of tangent u secant u is secant u. So we know we have that already. So we suspect then that our u is going to be 10x. So u is equal to 10x, du is equal to 10 dx, and I'm going to rewrite this. So I have tangent 10x secant 10x, and then dx. So I'm really close. I have that. I have the x, but I don't have the 10. So I'm going to add the 10 and the 1/10. I'm going to rewrite it with a u. So this is tan u secant u du. All of this goes to du. And so I have 1/10 of secant u. Well, u is 10x plus c. So in the next example, we have tangent squared x, secant squared x, and when both of them are squared, it's kind of hard to know which one of them should be u. So let's pick one. Let's let u be secant. secant x. And so when we take the derivative of secant x, if you look it up, is something horrible like the natural log of secant x plus tangent x. Well, absolutely fine. There is absolutely no way that we can get that when all we have is a tangent squared and a dx. So this is not it. This is not u. All right, so we're going to try the other one. So we're going to let u be tangent. When we say take the derivative, that's going to be secant squared dx. And if we rewrite this, we can see right away that those two things are the same. And so we know we found our u. So we know that u, this tangent x is u, so we're going to rewrite it as u squared du, which will be u to the third over 3. Now there's a tendency here, isn't there, to just take the derivative or whatever, but just integrate. The integration is just x u to the third over 3. So we're going to substitute then. We're going to substitute for u. U is tangent x, so we have tangent cubed x over 3 plus c. And that is our final answer for that one. Okay. Now, number 6, we can see that easier that that's under the radicals. So we know that the u on this case is going to be cosine x. And so du is going to be negative sine x dx. If we rewrite this, right, we have cosine x to the 1/2, and then we have sine x dx, and we're really close, right? We've got the sine x dx, but we don't have the negative. Okay, so we're going to rewrite u to the 1/2 du, and that's going to be u to the 3/2 over 2/3. Don't forget the negative, and then rewrite it. Negative 2/3, u is cosine x, I just looked up there real quick, to the 3/2 power plus c. And here's our final example, number 7. You can see here this is a little more complicated, but not too bad. We're going to let the part under the radical be u. So this is 1 minus sine x du. I have more room, I'm going to write bigger. Is going to be negative cosine x dx, cosine x dx, and negative cosine x dx, and then I'm going to rewrite. So I'm going to put the radical 1 minus sine x to the negative 1/2 power, and then cosine x dx. Don't skip this part where you're rearranging and putting them in the right order, because you can get lost in these problems really easily. And if you don't stay organized, and if you don't kind of do them the same way every time, then you really will you'll get lost. All right, so that's my du, so that needs to be negative, and so does that. I'm going to rewrite it, so I'm not even skipping that step. So this will be u to the 1/2, negative 1/2, du, right? And then I'm going to integrate. So I have negative, and then add 1, so this is 1/2, and then 2. So this will be negative 2 u, which is 1 minus sine x, to the 1/2 plus c. And there you have it. So here are a bunch of examples. We're going to do some more in class. I hope you took good notes, and once again, I hope you worked some of the problems ahead of me so that you can get extra practice on doing these, because really that's all you need is more practice. So I'll see you in class.